Chapter 2, Section 5, Absolute Value Functions and Graphs. Today we're going to learn how to graph absolute value functions. Okay, so follow along. A function in the form of f of x, remember that just means function, equals the absolute value signs. I'll zoom in a little bit for you. Absolute value signs of mx plus b, close absolute value sign, plus c. When m equals 0. That is what an absolute value function is. An equation in the form of y equals absolute values of mx plus b plus c is an absolute value equation with two variables. The graphs of absolute value equations in two variables, okay? Looks like angles. The vertex of the function is the point where the function reaches the maximum or the minimum. Okay, in general, what that means is the vertex of y equals mx plus b plus c is located at b over negative m. Remember that, comma c. b over negative m, comma c. The middle graph above, right here, the x-coordinate of the vertex is negative 4 over 2, negative sign. So you can see right here, negative 4, negative 4 over 2, it's just 2. Note that the graph of the first one, y equals absolute value of negative x, is a reflection over the x-axis of the graph y equals absolute value of x. So what does all this mean to us? Okay, let's go ahead and get started, and we'll talk about it. Graphing an absolute value function. Okay, so we have a graph, absolute value function. Y equals the absolute value of 3x plus 12. Okay, y equals absolute value of 3x plus 12. So we're going to write that down here in the bottom. Y equals the absolute value of 3x plus 12. Our vertex, if you remember, is negative b over m, comma c. Okay, that equation looks like this, so we can be on the same page. Y equals the absolute value of mx plus b, close absolute value signs, plus c. So what is our m value? Well, that's 3. What is our b value? Well, that's positive 12. What is our c value? That's 0. So our vertex we can kind of find is this. Vertex is negative b over m, so that'd be negative 12 over 3, comma 0. Well, so our vertex will be negative 4, comma 0. So we know if we plotted an x and y graph right now, our vertex would be x at negative 4 and 0. So we can plot this on a graph. Our y-intercept, or our y value is 0. So negative 4. 1, 2, 3, 4. Negative 4 is right there. Okay? Now, let's pick a number above negative 4 for x and a number below. And let's just solve. So let's just look at the equation. So again, I'm going to write our equation here. Y equals absolute value of 3x plus 12. Okay, we already solved for the vertex. We'll make that a v right there, vertex. So now let's pick a number above. Always pick 0 when we can pick 0. So when x equals 0, we get y equals the absolute value of 3 times 0 plus 12. So y is going to equal the absolute value of 0 plus 12. So y is going to be the absolute value of 12, which is 12. Can we plot that point? Yes. So we have a new coordinate right there, 0, 12. So let's plot it. So x is 0, y is 12. So we go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now let's pick a number below. Y equals the absolute value of 3x plus 12. We know at negative 4 is the vertex. So let's pick a number below negative 4. Alright. It does not matter. Let's pick negative 6. That should be an easy number. Okay. So y, this is when x equals negative 6. So y equals the absolute value of 3 times negative 6 plus 12. So y is going to be the absolute value of negative 18 plus 12. So y is going to be the absolute value of negative 6. What's the absolute value of any negative number positive? So y is positive 6. So can we graph that on this? Sure. So negative 1, 2, 3, 4, 5, 6. So we're right here. And up 6. 1, 2, 3, 4, 5, 6. Alright. So can we graph it? Yeah. From the vertex, we're going to go up to the first line and up to the second line. So we were able to graph using coordinate points. Okay, I'm going to leave it up there for a second. And let's do a few of these. Okay. So graph absolute value of 2x minus 5. So y equals the absolute value of 2x minus 5. So that's given. So let's just list some things. What's our m value? What's our b value? And our c value? Our m value is our slope. So that's 2. Our b value is our y-intercept of a normal line, so that's negative 5. And our c value is 0. So our m is 2. Our b is negative 5, and our c is 0. So what is our slope? Do we remember? Well, our vertex is negative b over m, comma c. Well, let's see what that would be. That would be negative 5 over 2, comma 0. So our vertex is going to be 5 over 2, comma 0. So let's plot points, x comma y. And if we said that's our vertex, what do we say we want to do? We want to pick a number above and below. So our x was 5.2 and 0. So let's write our equation. Y equals the absolute value of 2x minus 5. So let's pick a number below 2.5 or 5 halves. Let's pick 0. So when x equals 0, this is what we get. Y equals the absolute value of 2 times 0 times or minus negative 5. So y is going to be the absolute value of negative 5. So y is going to be 5. Okay, now let's pick a number above 2.5. So let's change pin colors. So we got y equals the absolute value of 2x minus 5. And again, one way to remember the vertex point, sorry to get off topic, one way to remember this, it's going to be equal to whatever makes that 0. Okay? So let's go back, let's erase that real quick. Okay, so let's pick a number above 2/5. Well, 5's a pretty easy one to plot. So when x equals 5, what do we get? Y equals 2 times 5 minus 5. So y is going to equal 10 minus 5, which is going to be the absolute value of 5. So y is going to be 5. Okay, so let's plot this on one of these graphs. So let's start with the vertex. My y value is 0, my x is 5 halves. So that's 2.5, right? So we're going to move 2.5 right there. That's the first point. Let's go to the number below. Let's plot 0, 5. So we go 0 up 5. We can draw a line. Okay, now let's go 5, 5. 5 up 5. What do you notice? It's this one right here. Alright. Excellent. Let's keep doing a few of these till we get it. Oh, now we got a c value. Not a big deal. So let's just look at our original equation. We know y equals the absolute value of mx plus b plus c. So let's find our m, our b, and our c values. What's our m in this equation? I got a negative on the outside. Okay. Well, my m is 1, my b is 1, and my c is negative 2. Okay, so let's find out what is our vertex is negative b over m comma c. So our vertex is negative 1 over 1 comma negative 2. So our vertex is -1, comma, -2. So let's plot that. Our vertex is -1, -2. So we're going to go left 1 and down 2. Left 1 and down 2. So that's not it. Left 1 and down 2. There we go. Let's use a different colored pen. Left 1 down 2. Left 1 down 2. Left 1 down 2. Left 1 down 2. So you can see right now the answer is going to be C, just because there's no other choice. But let's go ahead and solve. So we know the vertex is -1, 2. So let's set xy values. Let's xy column. What do we say we have to do? -1, -2. But let's set one above it and one below it. So y equals negative absolute value x plus 1 minus 2. So let's plug in when x equals 0. Here's what we get. Y equals negative absolute value of 0 plus 1 minus 2. Y equals negative absolute value of 1 minus 2. So that's going to be y equals -1 minus 2. So y is going to be -3 when that happens. Okay. So that's a number above it. Now let's pick a number below, -2. So now let's do this again. Y equals negative absolute value x plus 1 minus 2. Alright, so when x equals -2, it's going to be y is going to be y equals -2 plus 1, close absolute value sense. What's -2 plus 1? -1, right? So it's going to be negative absolute value sign of -1 minus 2. What happens to -1 inside absolute value signs? It just becomes positive. So there's a negative sign on the outside, so it's going to be -1 minus 2. So y is going to be -3. Okay, so now we can plot those points. Let's plot this one. We've already plotted that one. -1, -2. Let's go 0, -3. So 0 down 3. 1, 2, 3. And let's go -2, -3. Over 2, down 3. There you go, C. There's our graph. C. Okay. The other way to solve absolute value equations and graph them is to write two linear equations. So I'm just going to walk through the example here. I'm going to let you follow through the notes, and then we'll work some together. So we're given y equals the absolute value of x minus 3 plus 5. Okay, what we did before, if you remember, we found the vertex using the negative b over m, comma c, and then picked a number above and number below and graphed it. The other way, this way, is we can isolate the absolute value by itself like we did before. So in this case, we'll subtract 5 to each side. So we're going to get y minus 5 equals the absolute value of x minus 3. Okay, use the definition of absolute values. Write one equation when x minus 3 is greater than 0, and one equation for when x minus 3 is less than 0 like we did before. So when x minus 3 is greater than 0, we get y minus 5 is equal to x minus 3. When x minus 3 is less than 0, we get y minus 5 is equal to negative sign times x minus 3. So there's a positive solution set and a negative solution set. And then we just solve for each, and we get two linear equations, y equals x plus 2 and y equals negative x plus 8 once we do the math. And then we just graph each equation, okay? And then where they intersect, obviously, is the vertex. And then we're able to find our graphs. Okay? So here we go. Graph y equals absolute value of 2 over 3x plus 4 minus 3, right? By doing two equations. Okay, so we're going to have two equations. So I got y equals the absolute value of 3 halves x plus 4, close absolute value sign, minus 3. So let's add 3 to each side to get the absolute values by themselves. So we get y plus 3 equals the absolute value of 3 over 2x plus 4. Do we have the absolute value by itself? Do we have it isolated? We do. So now we can write two equations. So y plus 3 equals 3 halves x plus 4. Okay. And on the other side, we have y plus 3 equals negative 3 halves x plus 4. Okay, now let's just get y by itself in each equation. So we'll do the positive one first. So we'll subtract 3 to each side. So y is going to equal 3 over 2x plus 1. Can we graph that equation? We sure can. We'll do that in just a second. Okay. Now let's look at the other side. Let's distribute the negative sign. So I get y plus 3 equals negative 3x over 2 minus 4. Now we're going to subtract 3 to each side like we did before. So we're going to get y equals negative 3 over 2x minus 7. All right, so we have two equations. Can we graph them? Yes, we can. So I'm going to paste a graph real quick. I know we're on graph paper, but maybe this will help make sense to you guys. All right, so let's graph. We're going to graph the first one, for the one on the left first. So y equals 3 halves x plus 1. Okay, I'm going to use red for this one. So our y-intercept is 1. So there's this point. Our slope is 3 over 2. So up 3, 1, 2, 3, over 2, 1, 2. Okay? I can draw a line now with that information. Lucky for me, I have a handy-dandy line drawing app. There we go. Now, let's draw the second equation. Let's draw the second line we have. Y equals negative 3 halves x minus 7. So let's go to negative 7. And my slope is rise over run. So I'm going to go up 3, 1, 2, 3, and left 2, 1, 2. Up 3, 1, 2, 3, left 2. Okay, that should be enough points for me to graph. So let's draw my line. The y-intercept was negative 7, so here we go. There, I got a line. Let's extend this line a little bit further. Trying to go through with the points. Alright, and there we go. We have our graph. Okay, you can see the disadvantages of using the graph to do it. So there we go. That's what we have. So let's see if we have one that looks like this. So we should be intersecting somewhere near, looks like negative 3, negative 3. Alright, looks like the answer will be C. Most definitely C. So that's the other way to do it. You write a positive solution set and a negative solution set and draw the two lines. Okay, you can see there's the advantages of both. Okay, graph y equals 2 minus the absolute value of x plus 1 by writing two equations. So let's write the original equation. Y equals 2 minus absolute value of x plus 1. Okay, so let's subtract 2. So we're going to get y minus 2 equals negative absolute value of x plus 1. Now, basically, multiply each side by negative 1. So we're going to get negative y plus 2 equals the absolute value of x plus 1. Okay, so we have the absolute value isolated. So now we can make a positive solution set and a negative solution set. So let's do our positive one. Negative y plus 2 equals x plus 1. Okay, our negative solution set's going to be negative y plus 2 equals negative x plus 1. Okay? So let's work the left side first. Let's go through our steps. Let's just get y by itself. So we're going to subtract 2. So we're going to get negative y equals x minus 1. Now we're just going to flip the symbols to get y positive. So y is going to equal negative x plus 1. That's something we can graph pretty easily. So the other side is going to be negative y plus 2 equals negative x minus 1. So let's subtract 2 to each side. So I get negative y equals negative x, minus 3. Flip the signs. So I get y equals positive x plus 3. Can I graph this? Yes, I can. Okay. Okay, I'm going to plot my points in red. So the y-intercept in the red one is 1, and the slope is negative 1. So that means down 1 to the right one, down 1 to the right one, down 1 to the right one. Okay. Now let's plot the other one. Y equals x plus 3. Well, the y-intercept's positive 3, 1, 2, 3, and the slope is 1 over 1, so it's going to be looking like this. I hope you can see that well enough. All right, let's finish plotting some more points on the other one. Okay, you notice where we intersect at. Okay, I'm going to highlight that for us. That's where we intersect. So when we graph this, once we get our handy-dandy line app, now we can graph the lines. From that point, going on a slope of 1 to there. And from this point, going on a slope of 1 there. And there we have a graph. So there we have a graph with the vertex of negative 1 comma 2. So we can look at the multiple choice answers and see which one we have a negative 1 comma 2. Looks like the answer is going to be B. All right. Anything else on that? Moving on. Real world connection. Suppose you pass Betsy Ross's house halfway on your trip to school each morning. As you walk the rate of 1 city block per minute, sketch the graph of your trip to school based on your distance and time from the Betty Ross house. So when we start, okay, we see that we are 7 minutes away or 7 blocks away. So as we walk towards Betty Ross's house, time goes, so we're getting minutes and minutes closer, and we're getting blocks and blocks closer as well. Once we get there, so we're in a downhill slope till we hit the house. And then once we start going to school, we're walking at a block per minute. So we're walking nicely away. So we go up and down. So the equation distance equals absolute value of t models our distance from the Betty Ross house. So suppose you ride your bicycle to school at the rate of 3 city blocks per minute. All right, how would your graph change? Well, basically, what's our slope now? Our slope is 3 and negative 3. So our slope should be much, much, much narrower. So the new graph would look like C. All right. Review this, work the problems, get used to understanding what to do with the equations.